Hey fifth graders, Miss Shames here, and today we're going to dive into Module 7, Lesson 8, and we're going to be thinking a lot more about lines and rules on a coordinate plane. So our teaching point for today is that mathematicians generate a pattern from a given rule and plot the points. Let's talk about how you'll know if you're successful. What's your success criteria, or what should you accomplish by the end of the day? So by the end of this lesson, you'll be able to determine the y-coordinate of a point when the x-coordinate is given, but you have to be given the line's rule. Also, when given a line's rule, you'll be able to determine the x-coordinate of a point when the y-coordinate is given. You're also going to notice patterns in the coordinates of points on a line and identify the line's rule. And you're going to be able to plot points from a table based on its coordinate pair. So these are all the things that you're going to learn and practice today. What are some of the vocabulary that we're going to be using today in our mathematical writing and speech? So x-coordinate, pattern, rule, coordinate pair, y-coordinate, and line. So look out for these words and try to use them in your mathematical writing and speech. All right, let's get started.
Hi, Zerner. Today, we're going to work with the coordinate plane. I have some rules that describe the relationship between the x and y coordinates for points on a line. But I only know the rule and the x-coordinate. Can you help me crack the code and find each y-coordinate? Let's warm up with this rule. Y is 1 more than x.
Okay, so here we know the rule and we know the x-coordinates, but we don't know the y-coordinates. But we can find them using the rule that y is 1 more than x. So if x is 0 and y is 1 more than x, then y must be 1. If x is 3 and y is 1 more than x, then y must be 4. If x is 10 and 1/2, go ahead and turn and talk to a partner or type into the Zoom chat what would be the y-coordinate. So the y-coordinate would be 11 and 1/2 because that is 1 more than 10 and 1/2.
Y is 1 more than x. So the y-coordinate's value is 1 more than the x-coordinate's value in any given coordinate pair. Let's try this rule. Y is 5 times x. For each x-coordinate, what is the corresponding y-coordinate?
So now we know that y is 5 times x. So let's figure out the y-coordinates for these given x-coordinates. So when x is 0, y is 5 times 0, which is still 0. When x is 0.5 or 5/10, y is 5 times that. So I'm going to use a fraction to help me solve. I'm going to rewrite the 5/10 as 5 over 10 times 5, and I get 25/10 or 2.5. And when 1 is x, y is 5 times that. So y would be 5. Yay!
Great warm-up, Zerner. Let's dive in with some new rules. This time, we'll find each y-coordinate, write the coordinate pairs, and then plot the points. Let's try y is 1 more than 3 times x.
Ooh, this is tricky. It's almost like the rule has 2 parts to it because we have to do 3 times x and then add 1 more to that to get y. So let's think. 0 times 3 plus 1. So I know 0 times 3 is 0, plus 1 is 1. Notice that I'm always going to do the x times 3 first. Thinking about order of operations. Multiplication comes before addition. So 2 times 3 plus 1 and 3 times 3 plus 1. Go ahead and find the y-coordinate for the following two x-coordinates. You can turn and talk to a partner or type it into the Zoom chat. So for the x-coordinate 2, to find the y-coordinate, I would do 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7. And for the x-coordinate 3, I would do 3 times 3 plus 1. 3 times 3 is 9, plus 1 is 10. So the y-coordinate would be 10 on that point. Yay! All right, now let's plot the points on the coordinate plane. So I know for the first point, the x-coordinate is 0 and the y-coordinate is 1. So I'm going to not move anywhere on the x-axis and then go up to 1 for the y-axis. For the second point, the x-coordinate is 2. I'm going to go over to 2 and then up to 7. And for the next point, the x-coordinate is 3 and the y-coordinate is 10. All right. Yay.
Let's draw a line through these points like this. Even though we only have 3 points plotted, there are a lot more points that fall on this line. Think about this rule carefully. What is another point that would fall on this line?
Well, let's actually just look at the line and see if we can identify another point in its coordinates. So I'm noticing right here is a point. And let me try out the x and y coordinates and see if it follows the rule. So here the x coordinate is 1 and the y coordinate is 4. Let me see if that follows the rule. Well, 1 times 3 is 3, plus 1 is 4. So that does work. I'm going to put 1, 4. But notice how I used the line itself to help me solve and found where a point was on the line and then tried out the rule with its coordinates. Yay. Yes. All right, you guys, go ahead and work with a partner. You can pause the video to find the y-coordinates for this rule. Y is less than 2 times x. Pause the video to find the y-coordinate and then write the coordinate pair for all these x-coordinates, for all these points. Okay, so I'm going to show you how I would solve. So we know that y is 1 less than 2 times x. So think about order of operations. I'm going to start with 2 times x, which for the x-coordinate 2 will be 2 times 2, minus 1. So I know that 2 times 2 is 4, minus 1 is 3, so the x-coordinate will be 3. And the coordinate pair will be 2, 3. For the x-coordinate 2.5, I'm going to do 2.5 times 2 minus 1. I know that 2.5 times 2 is 5, minus 1 is 4. So the y-coordinate would be 4. And the coordinate pair would be 2.5, 4. For the x-coordinate 3, I know that I'm going to do 3 times 2 minus 1. Remember, each time the rule is that I'm doing 1 less than 2 times the x-coordinate. So 3 times 2 is 6, minus 1 is 5, and the coordinate pair would be 3, 5. Yay. All right, let's plot these points. So we have 2, 3. So I'm going to go over to 2 and up to 3, put a point here. 2.5, 4. So remember 2.5 is the same as 2 1/2. So I'm going to put that point, the x-coordinate, right between 2 and 3, 2.5, and then go up to 4. And then 3, 5. Take a look at these points, and what do you notice? Stop and think. Have your teacher call on you. What do you notice with these points on this coordinate plane? Yay. All right, so imagine someone drew a line through the points. Which picture would show the line drawn correctly? Would it be A or B? Go ahead and type into the chat or have your teacher call on you in the classroom. So the correct picture that shows the points is coordinate plane B, because this line goes through the points, whereas in A, the line does not go through all 3 points. Okay, this is asking us to name a point where the y-coordinate is greater than 10. And we know that the rule is y is 1 less than 2 times x. So in order to do this, I'm going to kind of go backwards. So I'm going to first choose a y-coordinate that's greater than 10. Let's just try 11. And then we kind of have to do this rule backwards. So when we were finding the y-coordinate, we did 2 times x minus 1. I'm going to go in reverse. I'm going to add 1 to 11. And then I know that this 12 is 2 times the x-coordinate. So 12 is 2 times what? Well, 12 is 2 times 6. So the x-coordinate must be 6. I'm going to double check my work by trying the rule going from x to y. So x times 2 is 12, minus 1 is 11. So in order to do this, we kind of had to go backwards, starting with the y-coordinate and doing the formula or the rule in reverse. So x-coordinate would be 6, y-coordinate would be 11. Yay.
Let's wrap up with some different codes to crack. Take a look at these tables. Which rule describes the coordinates in each table?
Go ahead and pause the video. You can work with a partner. Take a screenshot of this page if you need to, and then I want you to match the table with the rule that describes its coordinates. Okay, so this is what I'm noticing. In this first table, y is exactly 2 times x. 4 is double 2, 7 is double 3.5, and 8 is double 4. So that best goes with y is 2 times x. In this second table, in each y-coordinate, it's 2 more than the x-coordinate. 2 is 2 more than 0. 7 is 2 more than 5, and 9.5 is 2 more than 7.5. So we're adding 2, and it doesn't look like anything's being multiplied. So y is 2 more than x. In this last table, it fits the rule y is 1 more than double x, because double x, when the x-coordinate is 1, is 2, plus 1 is 3. Double x when the x-coordinate is 3 is 6. 3 times 2 is 6, plus 1 is 7. And when the x-coordinate is 4.5, double 4.5 is 9, and then plus 1 is 10. So it matches this one. Yay. All right, you guys, go ahead and head over to Desmos to get some practice, or you can get practice in your math workbook packet. See you soon.